This lesson is right triangle trigonometry. We're going to be learning about what trigonometry means. We have some trig functions called sine, cosine, and tangent. Those are new vocabulary words as well. Find out what those mean and solve for side and angle measures of a right triangle. We'll also solve some real-world problems involving angles of elevation and angles of depression using trigonometry. Trigonometry starts out a little bit tricky because it's so new, but eventually it all comes together and you're able to find out exactly what to do using the ratios and solving the equations properly. So it might not make perfect sense at the beginning, but it does come together and make a lot more sense at the end. In right triangles, just remember that the segment across from the right angle is the hypotenuse. And then we're going to be dealing with an angle of perspective. It's one of the acute angles. Based on which angle of perspective we're using, it determines how we name the other sides. The side that's opposite the angle of perspective, we call the opposite side. And then the leg that's next to the angle of perspective, we call the adjacent side. So we have the hypotenuse across from the right angle. The opposite is across from the angle of perspective, and the adjacent that's across from, or the adjacent is next to the angle of perspective. Remember, the angle of perspective is never the right angle. Also, we typically call the angle of perspective theta. It's the symbol theta. I'll draw it bigger here. Theta, and that is how it's spelled in English. That's a Greek letter. Theta typically refers to the angle of perspective. So, if angle A is the angle of perspective, let's identify the other sides. Across from the right angle is the hypotenuse. Opposite the angle of perspective is opposite. And the leg next to the angle of perspective is adjacent. When you're doing trigonometry, always identify the hypotenuse, the opposite, and the adjacent so you know which sides you're dealing with. So segment AC is the hypotenuse, segment BC is opposite, and segment AB is adjacent. So if the angle of perspective is angle A, then segment BC is opposite, segment AC is hypotenuse, and segment AB is adjacent. But if angle C is the angle of perspective, segment AC is still the hypotenuse. That doesn't change. But what changed was the opposite is now segment AB, and the adjacent is now segment BC. So when the angle of perspective changes, opposite and adjacent also change. The hypotenuse doesn't because it's always across from the right angle. But the opposite and adjacent do change. Make sure you can correctly identify those three sides. So if C is the angle of perspective, then we have some trigonometric ratios here to present. I'm going to put a theta right here where angle C is. One of the trigonometric ratios is called sine. We abbreviate it SIN, but it's actually SINE, sine. Sine of theta equals opposite over hypotenuse. Cosine, C-O-S, but it's really cosine. Cosine of theta equals adjacent over hypotenuse. And tangent theta, tangent, that's what happens to a guy when he stays in the sun too long. He becomes a tangent. Tangent theta is opposite over adjacent. And that looks really strange, those three formulas. Just remember, theta is an angle measure in degrees. Opposite, hypotenuse, and adjacent are side lengths. And what we know is the ratio of these side lengths equals the sine of the angle, the cosine of the angle, and the tangent of the angle. What this is going to lead to is us to be able to solve an equation, substituting in the angle measures and the side lengths with one unknown, and then we'll use our calculator, which will calculate the sine, cosine, or tangent. We'll do that, and it will help us figure out the missing piece. Now, how do you remember these formulas? Because this is a bit complicated here. What we have is these three words. SOHCAHTOA. SOHCAHTOA. So means sine equals opposite over hypotenuse. Ka means cosine equals adjacent over hypotenuse. Toa means tangent equals opposite over adjacent. SOHCAHTOA. If you remember SOHCAHTOA, you can remember these three formulas very easily. Remember that the sine, cosine, and tangent are all using theta, the angle of perspective. Sine of theta, cosine theta, tangent theta. In this example, we're going to use triangle LMN to find the sine of L, the cosine of L, the tangent of L. All of those will use angle L as the angle of perspective. And then we'll do the same thing with angle M. We'll express each ratio as a fraction and then as a decimal to the nearest hundredth. So if I'm referring to just angle L, that'll be my theta. Let's identify the side lengths. Across from theta is opposite. Across from the right angle is hypotenuse. And then next to theta is adjacent. Sine of L, which is opposite over hypotenuse. Cosine of L, which is adjacent over hypotenuse. And tangent of L, which is opposite over adjacent. That's where I'll start. Now, they give us the side lengths here. Little l, little m, and little n. Now, when they give us these side lengths, that means lowercase l side is across from capital L angle. Lowercase m side is across from capital M angle, and so on. So, across from angle L is 15. Little m is 36. Across from angle M is 36. And across from angle N is 39. So now I know my opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse. That's 15 over 39, which reduces, those are both divisible by 3. That's a 5/13. So that's my fraction answer. And then the decimal answer is about 0.38. Cosine of L is adjacent over hypotenuse. Adjacent's 36, hypotenuse is 39. So 36 over 39. That reduces to 12/13. And as a decimal, that is about 0.92. Tangent of L is opposite over adjacent. Opposite's 15, adjacent is 36. So 15 over 36. Those are divisible by 3. That's a 5/12, which is about 0.42. So let me include that fraction in the cosine. So there's sine, cosine, and tangent. Sometimes we're looking for the ratio. That's what we're looking for here. We're not looking for a side length or an angle measure. We're just looking for the ratio. So do your opposite, adjacent, and hypotenuse, and reduce it, get the decimal, answer it in whatever form they ask. Now if we want to do the same thing where angle M is the angle of perspective, we'll answer these. So now theta is at M. Across from angle M is opposite. Across from the right angle is the hypotenuse. And the leg next to angle M is adjacent. My side lengths are still the same. Across from L is still 15. Across from M is 36. And across from N is 39. Now the hypotenuse is still 39. Opposite used to be 15, now it's 36. Adjacent used to be 36, and now it's 15, so those have switched places. Sine of M is still opposite over hypotenuse, and now opposite is 36, and hypotenuse is 39. That's a 12/13, which is about 0.92. Cosine of M is adjacent over hypotenuse. Adjacent is 15. Hypotenuse is 39. That reduces to 5/13, which is about 0.38. Tangent of M, which is opposite over adjacent. Opposite is 36. Adjacent is 15. That reduces to 12/5, which is exactly 2.4. I don't need to round that one because that's exactly 2.4. So there's your ratios there. Also, remember to get these equations, just remember SOHCAHTOA. SOHCAHTOA. Sine of theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. Tangent theta equals opposite over adjacent. It's also worth noticing here that when I changed the angle of perspective, the value of sine and cosine switched. Sine of M is 0.92. So the cosine of L was 0.92. So when you switch the angle of perspective, sine and cosine switch. Also, cosine of M is 0.38. Switch the angle of perspective. Sine of L is 0.38. So when you switch the angle of perspective, sine and cosine also switch places, which makes sense because my opposite and adjacent switched sides as well. So just keep that in mind. It's one of the interesting properties of sine and cosine. Now we're going to finally use our calculator here because the calculator will calculate the sine, cosine, and tangent value for us. Sometimes they give you an angle measure and they say, take the sine of that angle measure or take the tangent of that angle measure. We need to make sure that the calculator is in degree mode. Remember, to get that, hit the mode button, and then make sure that when you have the radians and the degrees, make sure degrees is highlighted. Because if you're in radians, you're going to get the wrong answer. Make sure you are in degree mode. Keep in mind these numbers are different than what's on your worksheet. So use these numbers that you see on the screen. We're going to calculate this with the calculator. So sine of 94.4, and we're going to round to the nearest 10,000th, which is 4 places after the decimal. All I'm doing is I'm punching the sine button followed by 94.4 and then hit enter. Make sure you're punching that in. You get 0.9971. Tangent 28.5 degrees. Hit the tangent button, 28.5, enter. You get 0.5430. Cosine of 58.4 degrees. Hit cosine, 58.4, enter. You get 0.5240. Now you're probably thinking, what on earth do those mean? Well, remember what they mean. This right here, 0.9971, is the ratio of the opposite and hypotenuse side lengths. So I can use this number to help me find a missing side length if I know one of them. Same thing with tangent. The opposite and adjacent side length divide out to get 0.5430. So these numbers, they look funny, but they do come into play when we're solving for side lengths or angle measures. Now, what we did just now, we were given the angle, find the sine, given the angle, find the tangent, and so on. Sometimes, though, we know what that crazy decimal is. Sometimes you're given this decimal number, and then we need to find the angle. So when that happens, we take the inverse function. The inverse function, it's the opposite operation of sine. Just like addition is opposite subtraction, multiplication is opposite division, the inverse sine is opposite sine. And to do that, we need to use our calculator and hit the second button and then the sine button. And that brings up this. It's a sine and it has a -1. Looks like an exponent. That simply means that it is the inverse of sine. And what we do then is we take that of the decimal number and it will spit out the angle measure. Same thing with cosine. The inverse of cosine, hit the second cosine button, hit that crazy decimal number, and it will spit out the angle measure. So sine of the angle equals the ratio. That's what we just did a minute ago. But what if you're given that ratio, that weird decimal number? Arc sine. What I just said was arc sine. ARC sine. Arc sine of the ratio gives you the angle measure. So if you're given the angle, the sine of that gives you that ratio, that weird decimal. But if you're given the ratio, arc sine of the ratio gives you the angle. We also call the inverse of cosine the arc cosine, and the inverse of tangent is the arc tangent. So let's do something like that. Remember, for each of these, you're going to hit the second sine button, or the second tangent, or the second cosine of this decimal. So if you do that, you hit second, and then you hit the sine button, and above the sine button it says sine -1. Sine -1 should show up on your calculator. In parentheses, you're going to put 0.7823, and that will equal 51.5 degrees. Nearest tenth is 51.5. If you hit arc tangent, second tangent of 0.2386, that gives you 13.3 degrees. If you hit second cosine of 0.6461, the arc cosine there is 50.2 degrees. Now I want you to notice something else here. Remember how the arc sine of 0.7843 gives you 51.5? Now punch the sine of 51.5 degrees, and it's going to give you 0.7826. And the reason that that's not the same is because it was rounded. But look, 0.7826 versus 0.7843, that's pretty much the same number. So the sine of the angle gives you the ratio, but the arc sine of the ratio gives you the angle. Make sure you know the direction you're going so you can use the correct feature, whether it's the sine or the arc sine. Okay, now this is what it's all built up to. Finding side lengths or angle measures in a right triangle. I'm looking for x. I'm given a right triangle with an angle measure 25 degrees and the hypotenuse is 12. Well, we're going to call this angle theta. Draw across from theta, that's opposite. Across from the right angle is hypotenuse. The leg next to theta is adjacent. And now we need to identify whether we use sine, cosine, or tangent. Since my sides are opposite and hypotenuse, I'm not using adjacent. Opposite and hypotenuse, well, think. Remember SOHCAHTOA? Which one uses opposite and hypotenuse? And that's sine. Sine of theta equals opposite over hypotenuse. So I'm going to use the sine equation. Sine theta equals opposite over hypotenuse. And now I'm going to substitute my values in. Sine of theta is 25 degrees equals opposite, which is x, over hypotenuse, which is 12. And now I'm going to solve for x. Since this is x divided by 12, I need to do the opposite operation and multiply both sides by 12. 12 times the sine of 25, and make sure you put the 12 in front of the sine, not after, because that way you know that you're not doing 25 times 12. Instead, you're doing 12 times this whole thing. Equals 12 times x over 12. The 12s cancel there, which is what we wanted. X is approximately, and now this is where we're going to punch it in. Actually, let's not punch it in just yet. Let me write one more step here. X equals 12 times sine of 25. Now punch it in. I'm going to put approximately. When you punch 12 sine 25 in the calculator, you get, and what do they want? Nearest hundredth maybe? Nearest hundredth would be 5.07. So 5.07 is how long x is, and our unit is centimeters, so let's say 5.07 centimeters. Now make sure that's a realistic answer. One side's 12, one side's about 5. Yeah, that makes sense. Now, if you have one side 12 and one side is 5 million, you might have messed up somewhere. Or if you had one side is 100 and one side is like 0.0008 or something, you probably messed up somewhere. Mistakes can occur because you used cosine instead of sine, or maybe you used arc sine instead of sine, or maybe you're in radians instead of degrees. So there's several ways to make a mistake here. Just be as careful as you can. So what do? We were given the triangle. Identify opposite, adjacent, and hypotenuse. Then identify whether you are sine, cosine, or tangent. Write the formula, substitute in, and then solve. You shouldn't punch anything into the calculator until the last step. Once it says x equals whatever that is, then punch it in the calculator and round to whatever it says to round to.